Here I've got a short video on completing the square. This is a strategy that's used to solve quadratic equations. I'm going to go into a little bit of the background real quick of what we're actually doing, because we could just memorize the steps, but I want us to at least have a faint idea of why we're doing what we're doing. So what we're doing when I say completing the square is we have this idea that they're square numbers. And if I ask you what a perfect square number is, you might say, oh, 9's a perfect square because 3 times 3 is 9. And you might say, oh, 16 is a perfect square because 4 squared is 16. So this square number is just a number that's a product when some value is multiplied by itself to get that. So if you look down here, we have some perfect square trinomials, okay? And so remember, trinomial means these three terms. And what these are perfect squares because we have some value being multiplied by itself to give us this. We have x plus 3 times x plus 3, which gives us this product. We have x plus 2 times x plus 2, which gives us this product, and x minus 4 times x minus 4, which gives us this product. Now, just to do a little bit of quick background, we have to remember that x plus 3 squared is not equal to x squared plus 3 squared. I can't just take that exponent and stick it onto both. What it means is that x plus 3 squared is x plus 3 times x plus 3. Remember, the exponent means that it's that value times itself, which we've shown here. So just to show that this equals this, I think this is important to look at real quick. I'm going to multiply that out real quick, and I'll multiply these with what I call the box method. So I put one of my factors on top, one on the side, and I just fill it in as an area model. It's showing the product. So x times x gives me x squared, x times 3 is 3x, 3 times x is 3x, and 3 times 3 is 9. Now, what's on the outside is my factors, what's inside is my product. So you see I've got some like terms right there. And so basically I'm saying that the product of x plus 3 times x plus 3 is x squared plus 3x plus 3x plus 9. I got some like terms right there. And so I just want to show you real quick why x plus 3 squared is equal to this. Because when I go through this product, here's what happens. Okay? If you didn't follow this multiplying polynomials with the box method, just look at my videos. I have a video that goes into this more in depth. Okay? I kind of flew through that part. Now, next, what we're going to need to do before we can actually solve quadratics by completing the square is we need to realize the relationship between these two. So you may want to pause the video. I don't know what you want to do, but I want you to just kind of look at the factors in the product and say, what's the relationship there? If I gave you this, could you write this without multiplying it all out? I mean, yes, you could multiply it all out, but what's the process there? Okay? So if you need to pause it and think about it, that's fine. But what I'm really hoping you get, and this is true for all three of these perfect square trinomials, and this is only true for perfect square trinomials, but if I look at this middle term, that's our b value. If I take b divided by 2, it would give me 3. So let's say b equals 6. That means b divided by 2 is 3, which is that number. And then if I take b divided by 2 and square it, what's 3 squared? 9, which is that number. Now I realize that's a weird pattern and it's hard to put it in symbols in a way that makes a whole lot of sense, but excuse me, it's the idea that if I take my middle term, this b value, divide it by 2, and then square that number, it gives you the c value. Now let's look at our next example. If I take my b value, so b is 4, if I do b divided by 2, 4 divided by 2 gives me a 2, which by the way is this number right here. And then if I'm to take that and square it, take half of my b value and square it, I'm going to get 4, which is my c value. That's true right there. Okay? And then if I look at my last example, my b value here is a negative. It's negative 8. So b divided by 2 is negative 8 over 2, which is negative 4. And b divided by 2 squared is negative 4 squared, which is a positive 16. Once again, it gives us our c value. So this is true for all of these perfect square trinomials. If I take that middle term, divide it by 2, and then square that number, it's going to give me the third term, or my C value. If you looked at this, it would kind of show you why that's true if you really have a good understanding of what's going on in our multiplication. But let's keep that in mind, and let's go to an example. So we're going to start by doing examples with a leading coefficient of 1, and then we're going to do one example with a leading coefficient other than 1. So first, I've got this quadratic. What I want to do here is I want to make this into a perfect square. You can see there's no C term right now. So we just have the ax squared plus bx, but there's no C value. So let's start by making this a perfect square. So I'm leaving a little space there. So what C value would make this a perfect square? Well, hopefully if you're thinking back to these previous examples, you're thinking, okay, I can take my B value, divide it by 2 to get 2, square that value to get 4. And as you can see, we actually already looked at this example once. Let me bring it back real quick. We can see that that's a perfect square. If the B is 4, the C will also be 4, because you take it, divide it by 2, square it, so on and so forth. So we just took a 4 and added it there. Now, we can't just add random numbers to an equation and it's going to change the value of it. But I can do anything to one side as long as I also do it to the other. So I found that my C value is 4, so I added it to both sides, and I've still got a good equation. Our next step is to do this. I'm going to come back to this example. I know that this trinomial, if it's a perfect square, can be rewritten like this. Half of that B value will be right there. The number that we squared will be right there. And so the whole reason we write this as a perfect square is so we can rewrite it as the product of x plus 2 times x plus 2. And then the right side of our equation is 4. Let me fix this 2 up here. That's going to bother me. Okay? And so now we've got it written as such. And now that we've got that exponent, I want to get rid of that exponent, because remember, we're trying to solve for x. So I'm going to take the square root of each side of my equation, and then a second power, or something squared and square rooted, those are inverse operations, so they undo each other, and that just leaves me with x plus 2 on the left side of my equation. And on the right side of my equation, I'm left with a positive or negative 2. Okay? I have to consider both the positive and negative roots of 4. That's another video for another time, but for now, just trust me. And then we're going to solve for x. Hey, Tony, I'm making a video right now. Can you give me a few minutes? So I have x equals negative 2 plus or minus 2. And so I got to consider both roots. Negative 2 plus 2 is 0. And negative 2 minus 2 is negative 4. Let's do our next example. So I've got another example right here, and I am once again trying to turn the left side of this equation into a perfect square. So the 5 over here doesn't matter. That doesn't change anything for me. But I can take that 4, divide it by 2 to get 2, and then square the 2 to get 4. So it looks like I've got 4 again, but that's okay. It'll be kind of similar to our first example. If I add 4 to that side of the equation, I got to add 4 to that side. And the whole reason we write this as a perfect square is so that I can write it as its factors. So w squared plus 4w plus 4 is the same thing as w plus 2 squared. If you're wondering how I'm getting this value, it's b divided by 2. And that's equal to 9. So once again, I'm trying to get rid of the exponent. I'm going to square root each side of my equation. And here, the exponent will undo the square root, and we're left with w plus 2 equals positive or negative 3, because the square root of 9 is 3. I'm going to solve by subtracting 2 on each side and get w equals negative 2 plus or minus 3. Negative 2 plus 3, I think that's a 1. And negative 2 minus 3 is a negative 5. So those are my two examples, or my two solutions to that quadratic. Now, hopefully you're kind of getting the hang of this. We're going to make it a little bit more difficult, because we're going to do one with the leading coefficient that isn't 1. Okay? Notice that here, it starts with a 2. My a value is 2, where in my previous examples, they've all been 1. Because you know if there is no coefficient written there, you assume it's a 1. Now, pretty similar process. I want to get rid of the c value because that c value is keeping this from being a perfect square. So I subtract it from each side of my inequality. I'm going to give myself a little more space here. And then here's what I got to do to make this leading coefficient 1. This process doesn't work if this is some other leading coefficient. But what I can do is I see that leading coefficient is 2, so I'm just going to divide each side of my equation by 2. I can do anything to one side as long as I also do it to the other. And that will leave me with just an x squared. And negative 12 divided by 2 is, oops, I almost wrote a positive 6. That's going to be a negative 6. And the right side is negative 3.5. Now I can do this process just like we did in the previous problems. I'm going to take my b value, divide it by 2 to get negative 3, and square negative 3 to get positive 9. Keep in mind that a negative times a negative is a positive. That's why negative 3 squared is 9. I can do anything to one side as long as I also do it to the other. That's where those come from. And then the whole reason we write this as a perfect square is so we can write it in its factored form. That's going to be x minus 3 squared. Remember, I'm getting this value because it's that value divided by 2. If you don't believe me that this is the factored form of this, then multiply this out using your box method and you'll see that it's the same. That's equal to, I believe this is 5.5. And now I'm going to get rid of that exponent by taking the square root of each side of my equation. The exponent undoes the square root, and I'm left with x minus 3 equals positive or negative square root of 5.5. I'm just going to leave that under a radical because that's going to be some crazy decimal number. And then to solve for x, I'm adding 3 to each side. So my final answer here is x equals 3 plus or minus the square root of 5.5. If you wanted to, you could take that out into some decimal, but most teachers will actually prefer for you to leave it as that. So we worked through a few examples, as well as talked about kind of the idea behind completing the square. So just memorize these steps, and don't forget that if you have that leading coefficient, it's going to add this one step of having to divide by that leading coefficient everywhere.